Hello, this is Bobby Carlton from Innovation Women, and welcome to IW Speak. This is the Innovation Women Speak webinar series. And just for a quick introduction to Innovation Women, for those of you who don't know what Innovation Women is, we are an online visibility bureau. We are specifically designed for professional women, and we connect female speakers with speaking opportunities and event managers with awesome speakers who just happen to be women. And when you join Innovation Women, you get all this: social media amplifications, speaking invitations, a weekly list of calls for speakers that you can apply for. We promote you if you're an author. There are also speaker shout-outs, features in our newsletter, guest speaking opportunities through our webinar series like this one, and educational content as well that you can listen in on. We also do frequent in-person pop-up events with videographers for a live feed and a headshot. So if you're interested in joining Innovation Women, you can learn more through our weekly newsletter. You can sign up here on this bit.ly, IW sign up, or you can text INNO to 22828. And today we've got a special promotional code. It is IW Webinar Nancy for 20% off your first year. So that's good until midnight tonight. So if you'd like more information on Innovation Women, check it out. So before I turn things over to our guest speaker today, I'd just like to review a few things, some logistics, to help you with your experience during the webinar. So what you see here is an annotated version of your screen. Below the video viewing window, there are tabs. And the default tab is for asking questions. You can type a question in at any point during the program and we'll answer it. So actually, let's get started with that. A little bit of practice on using the question tab. Who's here today? Where are you from? And tell us a little bit about what you'd like to get out of today's presentation. So you can pop that right into the tab for the Ask a Question. There's also a voting tab that you'll see. That's where you'll be seeing a poll. So we'll also be launching a poll, and the tab will appear when we launch that. There's a tab called Rate. This enables us to rate the webinar and provide feedback for us if you like. We actually read all of that feedback, and it's helped us quite a bit with adjusting our webinars. So feel free to give us some feedback. And at any time, if you need audio help in particular, feel free to click on the Help button at the bottom of the screen. If you're using your phone to dial in, you may need to mute your computer audio. So we've got some folks joining us. Thank you very much. And absolutely, we are talking through, okay, we got some people from kind of all over the place here. So in that case, let's get started. And now I'd like to introduce Nancy Lee, who is our speaker for today. She is going to be talking about using IoT and machine vision to reduce traffic fatalities. And that's her helping out to reduce traffic fatalities. She is a product manager of IoT smart cities, blockchain and 5G and mobile edge at Verizon. So Nancy, I'd like to turn things over to you.
Hey, thanks Barbie for the introduction. How's going everyone? Thank you very much for listening to this talk during your lunch break. I've seen people introducing themselves through the chat. And do we have a chance to see the votes from the audience, Barbie? Regarding the background?
Yep, actually we've got some votes going on here. We're asking, what is your primary function or background? So are you in engineering? Are you a product or project manager? Are you in sales and marketing or government relations or something else? So if you can go and vote, that would be great. So right now it looks like we've got quite a bunch of things here. We've got some folks a part of a team, we've got some consultants, we've got some marketing people, engineering, government relations, so pretty much a mix, Nancy.
Awesome. Great. Yeah, in that case, I will make sure I cover very broad content of this talk. If anybody want me to dive into any specific details, feel free to let me know. Great. All right. So let's jump into this talk. My slides. All right. So I'm very excited for the specific topics regarding using the IoT and machine vision to help reduce traffic fatalities. It was because I have some personal attachment to the specific product and the mission we want to achieve. And let me tell you a story about a friend of mine. Actually, he's a coworker who's very working closely with me for 2 years already. And let's call him Jeff. So Jeff is in his early 40s with 2 teenager boys and happy family. And he just like majority of us working for Verizon, and he enjoys his day-to-day, and he also loves outdoor activities, such as he enjoys going biking to work, and also he goes windsurfing twice per week. And currently he's living in sunny California, the Southern California right now. And one day in December 2017, we found out that Jeff didn't show up to work. So we were very curious and also a little bit worried because Jeff was never late to any meetings. And the same afternoon, we found out that Jeff was hit by a car on the way to work. And he was found unconscious on the curb. And it was hit by a hit and run, and his bike was basically destroyed during the car accident. 2 weeks later, when I got in touch with Jeff's family, and I found out that Jeff was transported through air ambulance from Southern California all the way to Colorado. I was very curious and surprised that why we need to move him to Colorado. And later on, they told me that Colorado has the best hospitals for spinal injury. So Jeff was paralyzed due to the car accident. He wasn't able to move his body from neck down all the way to the feet. Even worse, his insurance can only cover up to 120 days of such expensive treatment. In the past, I've always asked myself those kind of philosophical questions. What's the purpose of life? What's the meaning behind it? I believe Jeff has his own definition, his own answer. He probably will wish he can teach his 2 boys how to do windsurfing one day. But this car accident totally turned his life upside down and impact his whole family, and including his work and the communities around him. What makes it very relevant to me and the people working on the specific product and the vision was that Jeff is one of the leading engineers working on the product we're launching today. So the purpose of the product is to helping cities to reduce fatalities and by car accident, including serious injuries as well. And this is the reason we're building this traffic fatalities product. Besides deaths, every year, more than 5,000 people were killed in a car accident in the U.S. And there are thousands more people with serious injuries, just like death. When we look globally, within the entire world, every 15 seconds, someone will be killed in a car accident. So this number, in addition to what we see today, has been keep on increasing because more people are driving, and in addition, the cost of the gasoline is also decreasing. So the more and more activities going on in this transportation space. And Verizon started to launch this product called Intersection Safety Analytics. Our goal is to help to improve the road safety for cars, bicycles, and the pedestrians. And this is the key reason we're building this specific product. And let me introduce another concept regarding what the whole world has been doing regarding enhancing the road safety. So a couple of years ago, there's a new initiative called Vision Zero. It means cities sign up for certain states to commit to eliminate traffic deaths and serious injuries. For example, within the U.S., 35 cities sign up for this mission, and Boston and Washington, D.C., and actually Boston's deadline is 2030 to achieve zero deaths. And San Francisco and Washington, D.C. have an even more aggressive goal. They want to achieve zero deaths by 2024, which is 5 years from today. Then we look into all the historical death data within the cities. We didn't see a significant drop due to all different kind of activities, which I'm going to introduce later on. So the cities have already signed up to such aggressive goals, but currently we're still trying to figure out as we trying to hitting the specific goals. And in addition, the Vision Zero activities actually came from Europe. In Europe, they already adapted zero death mission about 10 years ago. Actually, the best country who is able to achieve this mission is Sweden. Within the 10 years, Sweden already showed the data prove that they're able to reduce the deaths by 50% within half. They're still on their goal to try to achieve zero. But what we see today within the U.S., how can we help them to get the goal faster? And let's take a look at how this works today within the U.S. to get to the goal. And for example, lots of activities around how can we change the traffic signals, which is there's red light, yellow light, green light. Can I make green light longer or yellow light longer so that maybe cars will pass through intersection faster and using different traffic lights to control the speed of those vehicles. And there's also some other activities what they did was they're able to use some campaign, educational campaign, such as what we did in Boston. There's a lot of posters, and also whenever you register your car or renew your car in Boston, you will receive some kind of brochure saying Boston and Cambridge and lots of cities already signed up for this Vision Zero mission. And we are there seeking your help to drive safely to achieve zero deaths. Those examples of the education campaign has been around for a couple of years. On top of that, cities also have introduced infrastructure enhancement. What it means is if you live in Boston or within the U.S., you can see lots of cities already putting new bike lanes and like changing the pavement of the streets. We can also see that cities has been like moving the cars, the parking lanes outside to the road and have bikers like biking through the traffic in between cars so that they can make sure they are slightly safer than before. So those kind of changes towards the infrastructure enhancement. But what we learned was that there's still significant challenges with what do have done today in order to achieve the final zero death goals. And cities are facing the challenge regarding they're not able to understand the root cause of the car accident, which means if there's a car accident happen, was because car was speeding or pedestrians running a red light or car is making a left turn, didn't see the pedestrians. If you don't know the root cause, how you're able to implement your infrastructure changes successfully. That's something that's missing today. And in addition, there also lack of systematic data to make decisions. Through our interactions with the cities today, lots of times cities only capture like traffic death data, which only have limited information because lots of dangerous behaviors maybe didn't lead to specific fatalities, but it can lead to some small injuries, and those kind of data wasn't captured within the city's like database today. And on top of that, the cities capture those data is using some traditional methods. For example, they will hire some consulting companies to hang up cameras in the intersection for about 24 hours up to 3 days. And using the specific 3 days or 1 day data to understand what's going on in the intersection so that they can apply the knowledge to the whole year round and other intersections in the city. So we believe the way they make decisions wasn't using enough data. It's a little bit constraints and technology, and funding constraint, technology constraint, pushing them to go that route. And in addition, for the third part, cities are also facing difficulty to measure the success of the Vision Zero initiative. For example, in New York, every year the committee put in $10 million to improve the safety of the cities. But how can you measure effectively saying that the 10 million is able to enhance this effectively by reduce the traffic deaths by 50%? And would you only use the death data to reflect the effectiveness of the $10 million? I think there are many ways being able to measure the same outcome. And the other part is also the final part, as I also mentioned earlier, and cities making decisions only based on historical the death data, and there's lots of new ways we're able to help cities to enhance the decision-making process. I'm going to tell you more regarding what are the other ways to help them. So let's move on to talk about how do we learn about this process. So after we understand that cities are facing those data the challenges to enhance the road safety, we start to do some trial error, and we start the pilot with City of Boston as the very first city signed up for this new pilot and new mission, that we instrument one intersection within Boston, which is based on the historical data, has many deaths happen in the specific locations. If you live in Boston, you should be able to recognize the changes of the intersection, which is Beacon Street cross the Mass Ave, the intersection right off the bridge coming from MIT to Boston.
Know it well.
Yeah, you should already see the changes like in the intersections today. So the specific pilot we put in was starting from June 2016 until February 2017. And using that specific learning period, we collect 6 months data, and using this data to help cities to make some changes. And the picture down, the top picture you see is what it looks like through the normal eyes, and the pictures down below is what it looks like from an IR camera. So the camera is able to understand what specific locations, for example, the crosswalks, the pedestrians, and doing analytics of the specific intersections. And for this pilot, we put in 5 different sensor technology to instrument these intersections to help us to learn what kind of data can best help cities to enhance the decisions. And even more proud, the pilot we deployed in 2017 was awarded as Mayor's Best Practice in Boston. And through the success of Boston, we start to reach out to other cities and saying, There's lots of new things we can do. So in Boston, we implemented 12 different kind of use cases and help cities collect data to enhance the safety. And what about Sacramento, Palo Alto, and the Kansas City? When we reach out to them, each city starts to brainstorm with us and also tell the specific needs, because each city has different priorities. And for example, in Sacramento, we committed $100 million partnership with Sacramento. Their goal is to put in 10 intersections analysis for the city. On top of that, they also want to turn the entire city into a smart city to attract people working in the Bay Area to move to Sacramento and turn it into the third or the next Silicon Valley. And for Palo Alto, something quite similar. They're more interested into like biker volume, because the city somehow the bikers are more dangerous compared with other mode of transportation. And same thing as Kansas City, we did measurement regarding like speeding and jaywalking at the most busy street of Kansas City. So through those trials, we're able to launch our product. And what we learned was the product actually is able to address the following key needs for those cities, which include the measurement of different mode of transportation. And in the past, the cities mainly focus on vehicles and see where the cars is going. Actually, the people actually being killed in the car accident, majority of them are on the bike or the pedestrians. So therefore, we're helping cities to collect information for bikers and the pedestrians as well as those vehicles. On top of that, the product we produce is able to provide a dashboard, helps them to analyze the data. Soon I will show you what the dashboard looks like. And providing APIs for city to pull the data from our dashboard and integrate into other applications such as the open database for each city. They're able to do and other analytics using our data and integrate with other products at the same time. And we're also, as a Verizon, we'll also provide end-to-end support and service from beginning to the end, and include maintenance and the installation at the very beginning. And on top of that, this data we put in is able to help cities to secure additional funding to help them explore and deploy more solutions like this across out the entire city. So what does the product look like? So this is a summary of the specific data we captured, and each data, the lines down below represent a specific use case. And the picture on the right is the example of the dashboard we have. So specifically, what we measured for the city when we launched the product in last year, 2018, was that we're able to capture the speed of vehicles, pedestrians, and bikers, and mainly bikers, not pedestrians in this case. Then we count all different kind of movement, with the cars making right turn, left turn, and also with bikers making straight turns through the intersections. And where did the bikers go? Did the bikers bike on the bike lane, or did the bikers right away going through the traffic with the cars? And was the bike lane blocked in that scenario? And the same thing as the pedestrians, the jaywalking against the traffic light, or did cars run any traffic lights? And this is another very exciting new use case we're trying to launch in the near future, which is something called near miss. So specifically for near miss, what it means is when cars almost hit a pedestrian or almost hit a biker, but there's no fatality happening, which means like police officers not going to write down this police report about it. But those near miss is a great indication that something is a specific intersection or road segment is going to introduce some dangers in the near future. So for the city, we're able to introduce lots of new data in terms of near miss, that we're able to generate some kind of heat map to show the city, oh, in this specific road segment or this location or this specific right turn, there's lots of near miss. Cars almost hit somebody else, so pay close attention to here. So using the specific data, what city can do is that they're able to analyze what's going on in the road segment. They can also take actions in the near real-time functions, such as they can bring in police officers into the specific location within like 30 seconds. Actually, we have done this before. When we instrument the specific intersections, we have seen a car accident happening in the specific location, and the police officer showed up within 30 seconds. And those kind of real-time information is very valuable for cities and also for them to learn from the activities regarding enhancing the safety. All right, so this slide we're looking at is what exactly did we build the product. So what's inside the product today? So the product we launched regarding the name of product is Intersection Safety Analytics. And what is composed as software component and hardware component as well. So if we take a look at the lower left part of the picture, you can see there's a camera icon hanging on top of a light pole. So the camera is the key component into the solution. The camera is able to detect all the use cases I mentioned above, like speed, cars, and do the cars make left turn, right turn, and is this a car, what type of car, is it pedestrian or is it a biker? So the camera has its own intelligence built in to run algorithms to process the live video feed within the camera. So this is a key part of our product within the camera. So in the past, when I see cities, they're trying to using cameras to instrument their intersections or road segments. They usually have someone sitting behind the camera to watch the live video, or when there's dangerous behavior happen, they will go back to see the archive videos. There's no real-time processing of those videos. In addition, think about it, how much volume of the video you're going to send back up to the cloud and store them. What if we're able to analyze those videos on the spot and only send relevant information to the police officers or to the traffic engineers? So this is the invention we directly produce within Verizon. Verizon owns the whole IP of the smart cameras. We call the smart cameras. The camera is, as I mentioned earlier, it's going to run algorithm and detect the specific object as like cars, pedestrians, as we mentioned earlier, and understand the behaviors regarding where they come from, where they go to, and the camera will only send the post-processed data, we call the metadata, to the cloud. So you can see the upper cloud, the blue example of the cloud out there. This is an example of things we send to the cloud. And I don't think you can read it very well there, but what it means is it's all different kind of script. Doesn't mean anything to you because it's all like has security built in. What the script is representing for is that what the location, the GPS location of the object, and when did the object show up, and what is the speed of the object, and the direction of travel. So those information-specific text format of information will be transmitted to the cloud. And each object detected by the camera is able to have its own description in the text format and being sent to the cloud. Then on the cloud, we're able to display those information on the dashboard. In addition, we're able to match multiple sensors information. So let's talk about the multiple sensors. What I mean multiple sensors information. So besides the camera information I mentioned earlier, we also have another sensor down below, which is a traffic controller. You see the ones on the left corner. We also collect information through the traffic controller, which is a red light, green light, yellow light, so that we can capture the red light violation, or someone is going to a yellow light and speed up, or someone went to yellow light and stop. So those kind of behavior need to match with the traffic light controller's data. So we pull those traffic light, red, yellow, green lights information along with the video information, let them matched up in the cloud so that we can generate a very rich data set as we displayed in this dashboard. You can see this is a very comprehensive dashboard. So the traffic engineers, in this case, is our end users or data scientists within the city. The end users, that they are able to select specific use cases. In this case, it's the data they're looking for. Then they can choose which in what time segment. You can go down to every 5 minutes. You can also see the grand picture within every month, how is month being changed, or which day is more dangerous than the other day. Basically, you can break down all the data based on the analytical needs. And here, from Verizon's perspective, we are not going to, at this moment, tell city what to do, because basically we want their buy-in regarding how can they use our data. We will work with them hand by hand, saying this is what we observed. Based on heat map, we can tell that like Tuesday, 4 p.m. has high volume of near misses or cars making left turn running a red light. So would you want to take some actions around it? Then it's up to the city what kind of action do they take. They can either change the traffic light signal there, or they can send some police officer at 4 p.m. every day when they observe those high, like, dangerous behaviors. So in this case, we're able to get the end users buy-in and also capture their in-depth knowledge in the traffic management system. And here, what the tool is basically help them to make decisions. We call that it's a decision-making tool. And of course, those data can also be displayed through multiple different heat maps, and just overlay information, help them to see the data, visualize those data better. There is a specific component I mentioned earlier, which is key to our innovation, which is the smart camera. It actually has its own name called like Video Node 4K, second generation cameras. So this camera itself is able to do the video analytics inside the camera, which we'll also call them at the edge. So in this case, at the edge means you're not doing computation in the cloud, you're doing computation inside of the device right now. And the camera will also be able to have connectivity to it and sending the metadata, which is post-processed data, directly to the cloud. And itself also has algorithm for developers to do modification on top of it. For example, you can create like algorithm, also pull API, pull any kind of raw data if you want to. And on top of this, the technology we put in has lots of machine vision algorithms put in it. Our engineers use lots of AI technology and neural networks to detect what is a pedestrian, what is a car. And in this slide is a specific examples about what do you see from the camera's perspective. What is the magic smart camera is doing right now. So this picture is supposed to be a live video for this talk. We're not able to play any videos, but this picture is it's good enough to represent the information we want to deliver. So this is assuming you're looking at the camera, so you are the camera right now. So what the camera did was, first of all, whenever this object was in the field of view of the camera is able to tell, well, there is an object. You see they put them in the boxes. Then after they put them in the boxes, they will tell, and, well, based on the size of the image, this is a car, and the red one, the green one is a car, the red one is a pedestrian, and the blue one is a biker. And all this learning process through the AI, we're training the camera to learn. Anything looks like this, it's a car. We use lots of data to train our camera to detect specific what kind of object it is on this in the picture. Of course, we're also able to detect a very big object. In this case, it's a bus. After we detect this object, what we did next was the camera is able to track what is those objects coming from and the GPS location of it. So if you pay close attention, for example, see the red one, there's a pedestrian here, and you see this like tail behind the object, behind the little pedestrians, just like red like strip. So what this is that this is a historical location of the object, which means 2 seconds ago, the pedestrian, the red object, is closer into the intersection. As we move on, the object moves from something within the roadway all the way to the curb. Same thing as the bikers and the cars. And all these bubbles and the dots represent where they were before and where they are right now. So this is a very useful information because after you understand who they are and you understand where they go to and where they're coming from and did they make a right turn, left turn, those behavior is turning from two-dimensional picture into a visualized outcome of those like 3D data, so that from the traffic engineer's perspective, they're able to use this data to understand, okay, 2 seconds ago at this GPS location, this car was at this like crosswalk and he ran a yellow light or red light. At the same time, the specific location of pedestrians is 2 feet away from the car. Okay, this is a near miss. This represents some very dangerous behaviors, potentially will lead to something bigger in the future. So those information is being processed within the camera in real time and later on being used by those traffic engineers and the data scientists. And here's other examples we put in here. The other one I showed you earlier was a roundabout, but we're also able to use the camera, wide angle camera, to capture any, I think this is an intersection. Yeah, this is the intersection, and each car, we can capture almost all kinds of cars in the field of view and classify them as a car. And this camera specifically, I think, is hanging right on top of the traffic light arm. So you can see the entire intersection to capture data for our end users. And usually we're able to track 100 meters away from the left to the right for the entire travel path of this road segment. So we're able to detect very wide range of data. And same thing, actually, besides the intersections or roadway, we can also detect anomaly. In this case, it's wrong way. For example, the cars we detect in red was that everybody's driving towards forward, the same direction, but the red car is moving backwards. And the camera can immediately detect this is a red, this specific car. Let's mark them, let's flag them as a red car. And this car just went backwards. This is not good. And for some specific scenarios, for example, I got a chance to talk to someone in Middle East. Actually, they found us. They said they had a lot of traffic deaths in their highway. Was because sometimes the car will pull over on the side of the street. The car somehow miss the turn, so they want to go backwards and go into the next exit. And those very dangerous behaviors, something they want to capture today. So our camera can capture those specific behaviors within the camera and only send alerts and the text description to traffic engineers. All right, so this is the summary slide of today's talk. Besides the traffic safety solutions I told you earlier, Verizon has a portfolio of products we offer in the smart city space. So let's start from that very high level regarding what other aspects we're in. So within lighting space, lighting is a lower hanging fruit for all of us. Lighting is an old topic. It's been out for like more than 10 years that people try to change the light bulbs, try to save energy for the cities. But for lots of cities, for example, for LA, such a big city with, I think LA has like 8 million people living there. And only 50%, only half of the street light today is LED light. it's still like more than like thousands of old lights in the city today is not being fully optimized, and it's not saving enough energy today. So when we go into the city, try to propose and sell the new product, we usually go in as a bundle saying, hey, there's a lower hanging fruit. We can help you to change the light bulbs and the lighting control. On top of that, we can introduce those like AI, machine vision technology, help you to do other algorithms as well. So lighting is an important fundamental for our portfolio. On top of that, intelligent video. We talked about this multiple times, that being able to track lots of objects and apply this knowledge to many different scenarios. And also the public safety, which is the surveillance camera, is also the biggest investment within cities. The cities, for lots of cities, they spend about 10% of the budget on safety. The video surveillance safety, not just traffic safety. It's about like there's crimes in the city, those kind of safety scenarios with the city. So they're very interested in using smart cameras to detect these crime scenarios. And intelligent traffic, which is within the portfolio I'm managing today. Within intelligent traffic, we have traffic safety solution. We also have traffic congestion solutions. They're all using slightly different technology in helping city to achieve the same goal. And we also have parking solutions. Parking solution is using quite similar algorithms. The machine vision algorithm detects the parking spot for the lot, and helping the parking lot owners optimize the revenue and analyze those data. Surprisingly, parking industry is still very behind. They're still using some old technology saying, okay, if one person get in, you get charged $5. When people get out for 2 hours, you charge another $3. And those data is still not being fully used, and all those historical equipment was actually available more than 10 years ago. We discovered that this parking industry has lots of innovation need to be done in the near future. That's why we get into the space, introduce lots of new technology, machine vision into the space. Another part is Verizon also have a solution regarding citizen engagement. What we learned is if you go to New York a lot, Boston, and also San Francisco, those lots of cities, they have lots of kiosks out there. And the kiosk is helping city to enhance the engagement within the cities. For example, how can I help citizens to understand the new mission the mayor is trying to drive, and how can I help them to maybe charge the phone on the kiosk right now. So those lots of engagement need to happen within the city, and city trying to push today. All right, so this is a summary regarding what Verizon is providing, and before that we also talked about all the details regarding the traffic safety solution I personally managed and launched last year. Thank you very much for the opportunity to give a talk, and thank you for your attention. So I like to take any questions if you have any.
Yes, and actually we have a number of questions already, but if you are interested in adding your question to the list, please go and do that now. So Nancy, I have to thank you for starting off with Jeff's story. It sounds like this made this whole thing very personal for you and your team.
Yeah, it is. We're very determined to launch this product, helping more people.
Yeah, and speaking of timing and moving this forward, let's talk a little bit about the government sales cycle. What's that like?
Yeah, actually it's a very good question. And the specific field regarding selling to the government is also quite new to us for our team. What we learned was for the specific smart city space, the U.S. government themselves are always short in fundings, and updating those new technology in the city may not be a top priority for those cities. Usually those sales cycles are pretty long. For us, we will usually turn it from up to like 6 months, sometimes and up to a year for the city to sign a deal with us. And usually when we engage with city, we will create different kind of funding, like innovation within the city. Maybe we can start with a pilot for one like free trial, and later on with the commitment of the city where we will make them to pay for our product, and using different kind of subscription model or upfront fixed cost model for them to continuously get engaged. And the other part is some of the outcome we got from our pilot is able to help cities to get even more funding to pay for such technology. So therefore, we need to like innovate regarding how do we sell to the city today. It's quite fascinating.
Okay. And how is your product related to the 5G movement?
Very good question. Verizon actually already launched four 5G cities today within the U.S. And besides that, we believe that 5G is the main drive for enterprise customers. And consumers today, they can still use a 5G cell phone, but when you talk about enterprise customers, we believe that lots of applications can run on top of this 5G and edge computing initiative. So let me introduce another concept regarding edge computing. So when Verizon introduced the 5G, another new technology is called edge computing. Edge computing is something we talked about in the early presentation, that the cameras today can do computation within the camera. But if you can imagine that if all the old cameras in the city doesn't have to be replaced by smart camera, if they can offload the computation to the edge of the network, in this case it's on the small cell towers. The 5G has lots of small cell towers. If those small cell towers can do computation on behalf of those cameras, so all the cameras today will turn into a smart camera. So the deployment of those solutions will be way faster. So therefore, we believe lots of technology we have, or this specific product we build, can directly be tied into those 5G movements, so that you sign up for those 5G and edge computing technology, and we are able to upgrade your existing cameras or infrastructures to adopt into this new technology. So it goes hand by hand. This solution, there is the fundamental 5G and edge computing technology.
So we have another question here. You just talked a little bit about the smart camera. Someone's asking for a little bit more information about the smart camera and the algorithms behind it.
Yeah, if I can, let me go back to the slides, which we have the algorithm behind. Okay, so let me go back to the slides. Okay, so let's think about it in a relative higher level regarding algorithm. In the other slides we mentioned earlier, you can see there's a lot of cars. Let's use this one for now. Hold on, I think this one has more cars. Yes. The way we do it is, and where the engineers set up a neural network, so the way they do it is that send me tons of videos today. And then we hire lots of interns or have other people to do marking in the video, saying someone mark this, tag it as a car, and someone marks something else in the middle of the biker, said this is a biker. And then we run through tons, like hours of videos with all marked objects. Then the system is going to learn, saying in the future something look like this is a car, something looks like this is a biker. Then the algorithm is going to learn on its own. So this is pre-learned algorithm before we even launch this product. After the camera is able to learn what the object, where they are right now, then we can go back to the architecture diagram, this one. And then the camera will send something called metadata. So the keywords of metadata here is that the camera will describe each individual object. In this case is that we detect there's a pedestrian, this object equals to a pedestrian. GPS location equals to ABCD, and this is specific time, and this guy is also on top of a crosswalk. This is the zone, they're in the crosswalk zone. And all those information will then be translated into a encrypted text and sent back up to the cloud. This is what we described what the smart camera is doing right now. Hopefully this answers your question.
Yeah, and another question we have, what type of sensors are used in this system and how are they protected from the harsh environments found in different weather conditions?
Oh, very good question. Yes, I love this question. Actually, we have lots of discussions internally. So the equipment we use for this product, we mainly use some, I think this is another slide. Yeah. As we talk all the time, the smart cameras, we also have those kind of gateways, traffic controllers, and lots of connectivity box around it. And in the past, we also have in-ground sensors. Some of the sensors was being drilled in the hole under the ground and covered by mud or a pavement. And those, we call them magnetic sensors. The magnetic sensor is able to detect the car's movement as well. And on top of that, we also have pulled live API data of bus, right? There's in Boston and other cities, the bus data actually is publicly available regarding where they are, where they're going to, and when are they going to arrive the next step. And those data are also being pulled directly through API. For the physical data we put in on the street, how we protect them from the harsh environment is that, so in general, those cameras already went through certain standards saying under certain temperature or above certain temperature, this should perform on its own. And so far, we haven't seen any problem regarding just handing those cameras out there. We didn't put anything above it to protect from sunshine, anything, because the camera was built in to have a stronger, a weather environment resistance. Same thing as in-ground sensor. All those sensors, they have just higher standard when we build them to prevent all the weather conditions, which is the requirement we put in even before we start to design those devices.
So we have another question. LiDAR is an important part of autonomous cars, which seem to be a big component of future intelligent traffic systems. What do you think of LiDAR-based sensor systems for smart cities?
It's a really good question. So currently, LiDAR is mainly being installed on top of the cars right now. And based on my understanding of those LiDAR is that the price of LiDAR is relatively high. That's why the self-driving car price is still high right now. But LiDAR is a really good technology that potentially can be used for lots of smart cities applications. And majority of this today, I believe LiDAR is mainly used for the mobile solution. So the solution we put in the example I gave you guys is fixed solution, means I hand them at one location and I'm going to collect data for whoever passing through my zone. And for other examples for LiDAR, I think the application is mainly towards for moving objects. How can I use LiDAR to collect data within near real time on top of the cars or moving objects? So those are very, very useful for the detection as well. I've also seen LiDAR being used in other, like a factory environment or some kind of indoor environment. It's a very good way for people to detect and collect information, have very different wavelengths than 5G and other technology, which is more towards a complementary way for us to collect information. For example, in some scenarios, maybe the snow is too heavy. For example, in Boston, we just had a snowstorm. Potentially, the vision of camera will be impacted. But if we use different kind of technology, such as LiDAR or technology with different wavelengths, we potentially can still achieve the same result as well. So it's a complementary way to be used in the smart city space.
Great. Thank you so much. If you are interested in reaching Nancy, here is her contact information on Twitter, LinkedIn, and also an email address. And so thank you so much, Nancy. That was really an incredible presentation. I think I learned a ton, and I think everybody who's a driver interested in this information, or a pedestrian, a cyclist, we can all get something out of it. So be sure to sign up for our next Innovation Women webinar. This is next week, just in time for tax season. And joining us will be Rashida Matawala, a certified public accountant, MBA, and a manager at RJ Gold & Company. And she's going to be discussing the new tax law and how it affects you. Key tax reform for businesses and individuals explained. I'm going to be definitely interested in that one. We'll be sending out a link for all of our participants to register for that one. So thank you again, Nancy, for today's presentation, and thank you as well for joining us on the Innovation Women webinar series. Have a good day.
Thank you, guys.